Hey everybody, I just wanted to make this video on Signals and Systems practice quiz number 6. I know the last quiz was a little bit hard and a lot of people had problems with that quiz, but this quiz is actually fairly easy to complete, and I know that I'm not able to tutor this week because I have to do my own responsibilities. I have to do stuff with HKN. But I wanted to make this video for you guys because I think this quiz is actually one of the better quizzes. This is actually maybe even one of the easiest quizzes. And I just wanted to help you guys out and do the practice quiz with you guys. So let's get started. So for problem number 1, we have to find the output y of t of the following: low pass filter and band pass filter. If the input x of t function is given by, and it gives this really long equation, right? And it gives us the low pass filter and the band pass filter. So let's get started. With this type of problem, first you just want to focus on the low pass filter right over here. So it's set to 5. So basically the frequency has to be less than or equal to 5. All right. After we do that, we can actually see all the individual frequencies and compare that to 5. So let's start with 1.5 here. For 1.5, it's basically saying that there is no sine value. So this is basically 0, right? If this is 0, this is within the low pass filter. It's from 0 to 5, pretty much. With that being said, this will pass into the equation, y of t. So we're going to start with that. This will be our first term. Now we can actually start looking at the different pi values, and I'll explain why the certain signals or the certain signs will pass. So now we're going to look at, so we're going to do it like this. For 1/2, that was okay. We're going to try now 2 over pi, sine pi of t. All right, so it's like, okay, where do you start with this problem? Really, the only thing you have to look at is pi over here. So if you were to just type in pi on your calculator, or you guys, of course, probably already know this, pi is 3.14. Alright, so pi is equal to 3.14. And what does that tell us? 3.14 is less than 5. So this signal will pass. So this is going to be plus 2 over pi sine t. All right, that's good. And then we have the next one. Let me write that down over here. This is going to be 2 over 3 pi. This is going to be sine 3 pi t. Let me also give a check mark to this one because this one's going to pass. So sine 3 pi t. The number we're focusing on over here is 3 pi. So let's write that down right here, 3 pi. If we do 3 pi on our calculator, we will see that's 9.42. 9.42. Now that we get 9.42, we compare that to 5. 9.42 is greater than 5. So that means that this is not going to pass. So you would say that this is plus 0. And then we can just, from looking at the problem, we can tell, okay, if 3 pi is not going to pass, then 5 pi is also not going to pass. 7 pi, and on and on and on. So all the rest are zeros, plus 0, plus 0, and so on. So this answer will actually be y of t is equal to 1/2 plus 2 over pi sine pi of t. All right, so that is actually the answer to this problem. This is a fairly simple problem right over here. All you have to do is just look at the pi values, just whatever is in the sign over here, and compare it to the frequency. And you can see on the answer key, he actually revised the question. It originally included 3 pi, but 3 pi was just over 5, so he corrected that already. Anyway, going on to the next one, now that we know how to do this type of problem, we can start it off by saying, okay, so this is between the values 13 and 30, so I'm going to write it like this: 13 less than or equal to f, which is less than or equal to 30. Alright, we have that, and let me just write y of t over here. Since this is a very easy problem, I'm just going to start writing the answer, right? So we have 3 pi over here. This is 9.42. That is going to be less than 13, so this is not included in this signal. But next we go on to 5 pi. So 5 pi, go on the calculator, 15.7. 5 pi is equal to 15.7, and 15.7 is greater than 13. So we're going to write that in 2 over 5 pi sine 5 pi t. Alright. The next one is 7 pi, so we're going to write that in. 7 pi is 21.99, or 22, and that is greater than 13. So that is part of the answer as well. Where did my cursor go? There it is. So it's going to be 2 over 7 pi sine 7 pi t. Alright, and then we go on to the next one, 9 pi. 9 pi is 28.27, and 28.27 is greater than 13 and also less than 30. You also got to remember that the 30 is over here, so it's going to be greater than 13 and less than 30. So I'm just gonna write this over here, plus 2 over 9 pi sine 9 pi t, and then we're going to check the next value. So 11 pi. 11 pi is 34.55. 34.55 is greater than this. 34.55 is greater than 30. So that means we don't write that in. And by process of elimination, obviously, if 11 pi is not going to be written in, then 13 pi will be too high as well, and so on and so forth. So this is basically your answer to the problem. Right over here. Let me just get the whole thing. This is a very easy problem, and hopefully you guys, for the tests, it doesn't get any more complicated, right? Yeah, basically, there's not much else to it. All you have to do is compare what's inside the sign, and compare it to the frequency. If you guys could do that, then this question is basically a given. It is basically, you get half of the quiz from this one question. So, with that being said, we can now go on to the next problem, which is, I would say, a little bit harder. It's actually significantly harder, but it's not the hardest problem ever. So, let's move on to this. For the input x of t with x0 is equal to 0, xn is equal to 1 over 1 plus 2n squared times 1 plus jn, and omega 0 is equal to 1 revolution per second, and the circuit given below, find all of this, right? Find all of this. Alright. So we have this problem. Let me bring out my notes. Notes on how to properly do this. Okay. So, we have these givens over here, right? since we have those givens, we could do the first part. So we're tasked to find xn. There we go. I found it. It's right there. So apparently xn is given to us, and that's just free points right there. 1 plus 2n squared times 1 plus jn. I'm guessing he won't put that for the quiz, because that is way too easy of a problem just to copy what's given and you get free points. But anyway, that is the answer to the problem. xn is equal to 1 over 1 plus 2n squared times 1 plus jn. Now, we have something a little bit more complicated. So we're going to do the absolute value of xn. So, or this would be the magnitude of xn. When you have to do the magnitude of something, you could look at the problem like this. So we're going to do, if you have a problem where it has a plus jb, and you're taking the magnitude of this, then you would be doing something like this: a squared plus b squared, right? You're doing the square root of a squared plus b squared. Now let's take a look at this problem. Actually, let me try just moving this over. So I'm gonna just, whoops, copy this, put it, I'll just put it up here for now. There we go. And I'll write the magnitude of xn here. So let's take a look at this problem. One thing that I'll do is I'll actually distribute this to the top part, just so that it's easier to visualize. So 1 plus jn and 1 plus 2n squared. So we're actually going to be taking the absolute value of two parts. We're going to be taking the absolute value of the top part, the numerator, and the denominator. Because what happens is we have this one rule that states if we're taking the value of, let's say z over y, then you can also say that that is the absolute value of z over the absolute value of y, right? That's what we're doing over here. If you take the absolute value of this, there's no real number and imaginary number here, just like in this problem. Actually, let me just circle this one. This one has a real part, and this one has an imaginary part. If both terms are real, then this just stays the same. This stays as 1 plus 2n squared. If they're both real, then you just don't do anything with that. I could explain it why over here just really quickly. Let me do this in here. I'll actually redo this in purple. 1 plus 2n squared, 1 plus 2n squared. This is blue. And I'll explain it right over here to the right. So what happens is, if they're both real, then that's saying it's this, right? They're both a. The j over here is imaginary, but there is no imaginary parts. So this is kind of like it's saying plus j0, right? So if I were to go over here, it'd be like saying 1 plus 2n squared square root plus 0 squared, right? Because it's going to be a plus jb. If I do that, then this would be crossed out. You get this 1 plus 2n squared. After you do that, the square root and the square will cancel, so this will ultimately be 1 plus 2n squared. And that's the general reason as to why, if you only have real numbers, if you take the absolute value of it, it'll just come out to be the same thing. So that's that. Now for the top part, I'm going to do it right on the bottom over here. So let's do this in green. I'm going to do that here. I'm going to do that here. So we're taking the absolute value, 1 plus jn. Alright. So we have a real part and we have an imaginary part. So this is equal to 1 squared. Oh, there's a fire truck outside. Hopefully that doesn't get in the video, but anyway. 1 squared plus n squared. Right? So that will be equal to the square root of 1 plus n squared. Simple as that. You don't have to do any simplifying after that. This is just square root of 1 plus n squared. So this will go to the top over here. 1 plus n squared. And that's actually the answer for x of n. So I'll just rewrite it on the bottom over here in red. Absolute value of xn is equal to square root 1 plus n squared over 1 plus 2n squared. Alright, so we have that part. And the last part for, the last thing we have to find is angle of xn. So, how do we find the angle of xn? Angle of xn. Alright, to find the angle of xn, we have our own equation, and I guess I'll write it over here. So, to find the angle of xn, that's like saying we're finding the inverse tangent. Inverse tangent. Just make sure I'm getting this right. Yep, inverse tangent of b over a. So let's do that. This is actually not as complicated as you might think, even though it'll look complicated at first. So if you have the absolute value, or sorry, not the absolute value, the inverse tangent of b over a, the best thing to do is actually multiply this through. So first we're going to, I think the best thing to do is to multiply this through. So let's do that. I'm going to move this down a bit. Okay. And move that down. Okay. So let's just rewrite the equation from before. So it's going to be this times that, and this times that. All right. Okay. So let's do 1 over 1 plus 2n squared times 1 plus jn. So that's equal to 1 over 1 plus 2n squared plus jn over 1 plus 2n squared. Okay, so that's what you get. This will be your A, and this is going to be your B. Let's write that over here. This is equal to inverse tangent of b over a. So this is going to be really big. N over 1 plus 2n squared divided by a, which is 1 over 1 plus 2n squared. And that seems really big, but that's because we can actually do keep change flip over here. There's a division sign, there's a top being divided by a bottom. So we can just do the reciprocal of that. So let me rewrite it so that you guys will be able to see it better. This is basically saying n over 1 plus 2n squared divided by 1 over 1 plus 2n squared. So this is inverse tangent of n over 1 plus 2n squared times 1 plus 2n squared over 1. High school mathematics coming back. All right. With that being said, we could cross these two out, and then you finally get inverse tangent n over 1, or finally inverse tangent of n. Right? Obviously, you don't have to do all these steps. You don't have to explain all this in the quiz, right? You don't have to do change that into the division sign over here and then multiply it. No, you don't have to do all of that. That's just to show you guys the full explanation. You can actually go straight from this step to this step, right? And I would actually advise doing that because that saves the most time and it's actually the easiest way to do it. So, but I just like showing the full explanation just in case you guys like miss out on a certain step and you need me to go back. So there's that. Now we have to go on to part 2. Okay, part 2. So now this gets a little bit more complicated. This should also be part 3. This is part 3, and this one would be part 4. Right? Okay. So for part 2, you have to find hn omega 0, h0, absolute value of hn omega 0, and angle of hn omega 0. Okay. So let's do that. How do we find hn omega 0? Okay. So first, let's do something like this. Let's do this. So hn omega 0. Omega 0 is actually given to us at the top over here. Omega 0 is equal to, actually it's on the bottom, continues, 1 RPS. So omega 0 is equal to 1. That means this hn times 1, which is just equal to hn. So I'm going to be writing hn for the rest of this. But if he gives you omega 0, like a different value of omega 0, then just write whatever value he gives you on the quiz. So if omega 0 is pi, then write pi, h pi n, or hn pi, whichever. Anyway, to find hn, you're given this, right? Y of n over x of n. The identity would probably have like an omega 0 over here, but we know that omega 0 is 1. So it's going to be y of n over x of n. Alright. The best way to actually look at this is actually, well, let's take a look at the problem. This is where we actually use the circuit over here. This circuit. So we didn't have to use the circuit for the first part, but for the second part, we definitely have to use this. So you have a capacitor in parallel with a resistor. To do this type of problem, you have to use current divider. If you had a problem that was similar to, let's say the problem was actually like this. Hold on. Right? If it was like this. Then you would have to use voltage divider because this is in series. So just keep that in mind for the quiz. When it's in parallel, you use current divider. when you have it in series, use voltage divider. And I'll probably do an example later on how to do voltage divider, but let's just carry on with this. Let me just remind everyone how to do current divider as well. So let's say you have this, right? You have your source, and you have Z1. This is going to be Z1 in parallel with Z2. And you're trying to find, it says over here, Y of t is going through the capacitor. All right. So Y of t is going through here, Y of t. If you're trying to find the current going through this resistor or impedance or capacitor, whatever it is, inductor, then the equation will actually be Z1 over Z1 plus Z2. And actually, I think I could do the voltage divider right next to this, so you guys can see the difference. So you have your source, and you have Z1 and Z2. And you're trying to find this one. This one is going to be Y of t, right? This one would be Z2 over Z1 plus Z2. All right, so did you guys notice the difference? Let me just make sure that these are Z's, right? You guys notice the difference over here. So if you're trying to find the current going through Z2 in a current divider, then you would actually use the opposite value, Z1 over Z1 plus Z2. For voltage divider, I could actually label these voltage divider and current divider. For voltage divider, if you're trying to find Y of t for Z2, then you would use Z2 over Z1 plus Z2, right? So keep that in mind for the quiz. If you use the other one, well, just please don't use the other one. Don't use the wrong one, I should say. If you have a series circuit, remember to use voltage divider, and if you have parallel, remember to use current divider. I can't say that more than what I'm saying now, right? This is very important for you guys to know. So, since we're using current divider here, let's move on with the problem. Come on, Charlie. You gotta get onto the problem. People are waiting. Okay, so for current divider, okay. One other thing that I want to mention. Okay, so I'm not even gonna continue with the problem here. But when you have a capacitor, that should be equal to 1 over, I believe it's Jn omega naught C. Yeah. So this is for the capacitor. For an inductor, this is equal to Jn omega naught L. And for a resistor, this is equal to just R, right? So when we're going into, what is this, Fourier or Laplace, I don't remember. But when we're going into this notation, we want to change these values into this. Right? We want to change both of C and L into this value, and we do have a capacitor in this problem. So let's take a look at that. We have a resistor, and we have a capacitor here. So this one is going to be this over this plus this. So let's do that. So let's do, yes, HN. Yep. Okay, let's do that right here. So for HN, finally getting onto this part of the problem, finding HN, this is equal to So the resistor value, which is 1, I could actually write it in this notation. So R over R plus 1 over J n omega naught C. Okay, and if we sub in the values, this is going to be 1 over 1 plus omega naught is 1, as we said before, is 1 RPS, and C should also be 1, I believe, right? Yep, C is 1 farad. So this is going to be 1 over Jn. Now you could leave it like this, but there's actually a better way of writing this. We have this 1 over Jn over here, and that is kind of annoying to look at. So we're going to multiply the top and bottom by Jn. Right? If you have Jn divided by Jn, that's basically saying 1. Jn divided by Jn is 1. But this will be able to see this part better. So let me show you what happens. H of n is equal to, so 1 times Jn is Jn. And then for the bottom part, Jn times 1 is once again Jn. Whoops. It's once again Jn. And then Jn times 1 over Jn, that's equal to 1. So we could rewrite this as, let me write it in red, Jn over 1 plus Jn, and that's our answer for h of n. So it's a little bit, more complicated trying to remember like all of this. Current divider, voltage divider, but you should be able to remember that from like circuits, right? Just remember Z1 over Z1 plus Z2 for current divider, and for voltage divider, Z2 over Z1 plus Z2. Anyway. So now we have Hn. Alright, and then we have to do the absolute value of Hn. This one isn't too hard. Yep, this one isn't too hard. Okay, so the absolute value, whoops. Absolute value of Hn. So this, as I said before for Xn, would be the absolute value of the top divided by absolute value of the bottom. Right? So, so similarly, you know how I said before that if you have, a real number like a squared, right, and you have no 0, then this would eventually turn into a, right? The same thing goes for if you have 0 squared plus b squared. So if you have only imaginary terms, it'll actually still turn out to be just b. So if I do that up for you guys right now, this is, there's no real terms on the top here, so this is going to be 0 squared. This is going to be added to n squared, which is equal to square root of n squared. These cancel, and you get n. Very nice, very nice. So that's the top part. The bottom part is 1 plus Jn, which I think we've done before. Have we not? Yep, right over here. 1 plus Jn. This is also equal to 1 plus n squared. So, or the square root of 1 plus n squared. There we go. So this is already done for us. Square root 1 plus n squared. And I could actually just rewrite this in red so that you guys see that this is the final answer. N over square root of 1 plus n squared. We can't really do anything after that. Alright, so now that we have that, we can find the angle of Hn. Now the angle of Hn has a little extra step, but it's nothing too bad. HN. So the angle of HN, you're doing the angle of the top, so angle of JN, over the angle of 1 plus JN. All right, so this one is an interesting one. The first thing that I have to say is another identity, or I don't know if like what you would call it, but if you have the angle of A over B, this is also equal to the angle of A minus the angle of B. And Professor Osterich should have a sheet or something like under the Fourier series transform, I believe. It might be for its like applications or something like that. It's a PDF that should be on Moodle, and it should show this identity. So you guys can take a look at that. But I just am rewriting it for you guys. So that's the first thing that you have to know, and that's actually pretty easy to understand. But I actually want to talk about this, the angle of JN. Alright, so how do I want to do this? How do I want to explain this? The angle of JN. I know. Yes, I have this up here. You guys didn't know this, but I wrote something up here because I knew I had to talk about this later. Alright, so I'm going to explain this using the calculator. So if you go on your calculator and you hit mode, you can see that that's right over here. Let me show it to you on here. You hit mode, right? I want you to put it in degree mode and in this RE to the theta I mode. All right, so I want you to put it in that mode. It's probably like maybe in real and in radian before that, but just put it in those two modes. Once you do that, we're gonna plug in values for n, right? So let's do, so we have JN, all right, and we're gonna plug in for n is equal to 1, which is also equal to j. In mathematics, we use I. But in electronics or anything in electrical, we use J, so they're interchangeable. To get I on your calculator, it doesn't show in any of these images, but if you look at the decimal point, it should have I right there in blue. So you would press second first. So second first, nice. So you would click this second button, which gets it in this blue thing, and on your calculator it'll probably show up as an arrow, and then you click the decimal, and that's how you get I, right? So I want you to hit I, and then just simply press enter. When you hit enter, you should get 1e to the 90i. So this is basically saying that this is 90 degrees, right? And we just reminding you guys, we are trying to find the angle of JN, right? But let's keep going. So we have JN, and now we're going to try n is equal to 2. So this is equal to 2j. If you put in 2i on your calculator, you still get 90. The magnitude, this is actually the magnitude, this changes, but no matter what, you still get 90 degrees. If you put in 3, you still get 90. No matter what number you put in for n, you're always going to get 90. That is a pattern. Even if you put in 0i, I still think you should be able to get 90. But I think it's actually no. I don't think you'll be able to get that. You'll probably get 0. But this is just letting you guys know later. This is the summation for n is equal to 1 to infinity. But I'll be explaining that after we do the y of n part. So no matter what number you put in, you're always going to get 90. And there's one thing I have to explain. 90 degrees is equal to pi over 2 radians. So we're actually going to write it like this. Let me get back to here. So this part, angle of jn, hopefully I haven't confused you guys. Angle of jn, this is equal to pi over 2. Right? Because no matter what number you put in for n, you're always going to get 90 degrees, right? You might get that the magnitude changes, but you're always going to get 90 degrees. For this part, though, this part is a little bit different. This part we actually did before as well. So you were starting to see a pattern here. Right over here. Angle of xn. This one was the angle of 1 plus jn. And what do we get this to be? We got this to be inverse tangent of n. So, just as a reminder, we're going to be subtracting the angle of b. So this is minus tan inverse of n. Right? This is equal to this. All right. And the last thing I can do, of course, is write that in red, because that's the answer. So pi over 2 minus tan inverse of n. And that's equal to the angle of hn. All right, so that part wasn't too bad. The hardest part was actually just doing the circuit, just trying to remember current divider and voltage divider. But this isn't too bad. I think I probably forgot one part. I think I forgot H0, right? Yes, I forgot H0. Just remember to just not forget anything. Remember to just look over the problem and see what you're trying to find. H0 is actually very, very simple to find. So if I look back to Hn, we found Hn to be this value, Jn over 1 plus Jn. So I'm going to rewrite that over here. Hn is equal to Jn over 1 plus Jn, right? So that must mean that H0, we plug in 0 for everywhere we see n. So this is J0 over 1 plus J0, which is ultimately 0, right? 0 over 1 is equal to 0. Very simple. So that's part 2 right there. That's all of part 2. Now we just have to do part 3, which is the y. As I said, if you can find anything, any way to simplify this, like any way to simplify my answers, that's actually the best way to do it. I'm just doing it a very, very long way just so that you guys understand this better. For part 2, we're trying to find y0, yn, absolute value of yn, and angle of yn. All right. So actually, he says to do y0 first. We're actually going to do yn first. Yn, we have an equation for this. Yn is equal to xn times hn. All right. We have both xn and hn. So I'm going to write that down right now. So yn is equal to 1 plus, I could write that in brackets here. Yep. So 1 over 1 plus 2n squared times 1 plus jn times hn, which is jn over 1 plus jn. And at first I thought, oh my god, this is like such a hard problem. And I actually tried multiplying it through, and I was just like, this is way too big. There's no way that this can be the answer. I thought I had done something wrong, and I used the wrong values. Nope. All you have to do is just say, oh, we have a 1 plus jn on the bottom here, and we have a 1 plus jn on the top. And there you go. They cancel out to give you jn over 1 plus 2n squared. And on the equation sheet, by the way, so if you, or not the equation sheet, but the answer key, if I have any, if Professor Osterk has any different answers, so like right over here it says n over 1 plus 2n squared. I already checked it over with him. He said that he just did that. He just wrote the wrong answer there, but that's okay. This part is supposed to be what I already wrote. And also this part over here is going to be different as well. I think this one, y of n and y of t, should be correct, and everything else should be fine. But just wanted to let you guys know that. He also sent out a revised version, I remember, for correcting the top part because it included the 3 pi. But anyway, I digress. Alright, so we have that. Now we can find y0, which is once again just putting in 0 to everywhere we see n. I forgot. Write this in black. So y0 is equal to j0 over 1 plus 2 0 squared. Right, and that'll once again give us 0. Right, 0 over anything is 0. In this case, it would be 0 over 1. Absolute value of yn. Let's go with that. That's the next part. Absolute value of yn. We're almost done with this problem, guys. Don't worry about this. Absolute value of yn. That is equal to the absolute value of xn times the absolute value of hn. Okay? So this, we have the absolute value of xn and we have the absolute value of hn. So this is going to be 1 plus n squared, 1 plus 2n squared times n over square root of 1 plus n squared. These two cancel, so the value will be n over 1 plus 2n squared. Let me just make sure that I'm recording. That would be kind of embarrassing if I wasn't recording this entire time. Yep, I'm doing good. 40, what was that, 49 minutes? Yeah, you guys definitely won't take this long for this type of problem. This can be done in like 10 or 20, the whole quiz can be done in about 10 or 20 minutes. So anyway, as I said, I was just doing it the very, very long way just to show everything. Anyway, now we go on to the angle of yn. This one's going to be a little bit different. This one's going to be the angle of xn plus angle of hn. this is going to be equal to, so the angle of xn is equal to tan inverse n, and that's going to be plus the value of hn over here. I'll write it in brackets, but you don't actually have to write it in brackets because it's just being added. So pi over 2 minus tan, whoops, inverse, whoops, n, right? So we have a positive tan inverse over here, and we have a negative one. They have the same values on the inside, so they cancel out. So our final answer is going to be angle of yn is equal to pi over 2. Alright. And I think that's it for part 3. Oops. Yep, that's it for part 3. And the last part to do is the output yt. So we have an equation for that. Alright, the equation for yt is yt is equal to, what is yt equal to? Yes, okay, the equation for yt is equal to y0 plus summation n is equal to 1 to infinity to absolute value yn, n absolute value sign, cosine, really? Yeah, cosine n omega 0 not t plus angle of yn. Oh my god, that's a big equation. And basically, wait, hold on. Let me just make sure. Yep, it's multiplied by cosine. Basically, all we did here, the whole purpose of this equation, or sorry, the whole purpose of this problem was to find xn, to find hn. Once you find those two, you can find all of yn, and then with all that information, you could find the absolute values, the angles, and also the zeros, right? So that you could finally get this equation over here. We have y0, we have y0, we have absolute value of yn, and we have the angle of yn. So let's just rewrite that. I'll just do it in red over here. So y of t is equal to y0, which is 0, plus the summation of n is equal to 1 to infinity, 2 times absolute value of yn, which is equal to n over 1 plus 2n squared, times the cosine of n omega 0, omega naught t. Omega naught is 1, so this is just going to be nt, plus angle of ymn. Oh, wait, not. Hold on. Pi over 2. There we go. And that's the answer to this problem. That's the final answer. This is actually, this is mostly just like you have to remember the equation. Just memorize the equation, and these are free points right over here, because if you get y0 correct, if you get absolute value of yn correct, and you get the angle of yn correct, then you'll surely get this problem right, as long as you remember this equation. And this problem is, fairly simple compared to like a lot of other problems that you might see in signals and systems. This one isn't too bad. This might take up a lot of work, but of course I explained it as much as I could. I tried to like even do the reciprocal over here, right, which I didn't have to do, and of course you guys probably shouldn't do. You guys would just be able to notice this, and notice that it's 1 plus 2n squared, and you could cross that out with the other 1 plus 2n squared, and that'll give you n. But I just wanted to make sure that I could be explicit as possible. But anyway, that's pretty much it for this lesson. As I said, this is a fairly easy quiz. If you go through this, if you look through this video, and you're able to like do this problem, you should be ready for anything on the quiz. Hopefully, of course. But also be sure to like maybe even play this video on 2x speed or skip around. You don't have to watch the full video, of course. But as I was saying, I hope you all understand a little bit more about how to do this practice quiz. If you have any more questions for me, you'll probably be able to leave me a comment. I think I'm going to be posting this onto YouTube, and I'll just like share the video link with you guys. Or you could DM me directly on Discord. Probably best not to use the email. I don't really check the email too much. Just DM me on Discord, and I'll be able to get back to you as fast as I can. But once again, thank you for joining me, and I hope you all have a good night. Whoop.